Variable area flow meters are used to measure the volume flows of liquids and gases. They consist of a vertical conical measuring tube which widens upwards and a specially formed float which can move up and down freely in the measuring tube. Together, the reference position of the float and the measuring tube create a variable ring orifice. The higher the position of the float, the larger the ring orifice, and therefore the cross-sectional area through which the medium can flow past the float. This is the origin of the English designation of the device. When there is no flow, gravity keeps the float at the bottom end of the measuring tube. As soon as the medium flows through the tube from bottom to top, the float rises again, until the acting forces are in balance. I'd like to explain this in more detail. Three main forces act on the movable float. The gravitational force W, weight, operates downwards as the reset force, whereas the buoyancy force B and the flow force D, drag, work in an upward direction. The position of the float is a flow indicator. The gravitational force and the buoyancy force are constant for a specified application. Only the flow force can vary temporarily, as a result of a change in flow which moves the float into a different position. I would like to illustrate this with an example. Let's take as our starting point a state of equilibrium of the forces. That is, the float remains immobile in a certain position with constant flow. If the flow increases, the flow velocity in the ring orifice also increases, and correspondingly the flow force as well. The float rises. With the higher position of the float, the ring orifice, however, also becomes wider. So the flow velocity in the orifice sinks again, and the flow force returns to a state of equilibrium. The physical operating mode shows that the position of the float is a flow indicator. With glass cones, the flow rate can be read on a scale on the measuring tube itself. With metal cones, the float is not visible, so they have a magnetic transfer onto the pointer. For this purpose, a magnet is built into the float. Through a magnetic coupling installed on the pointer axis, the linear movement of the float is converted into the rotary movement of the pointer, which displays the flow on a scale. Once again, no auxiliary power supply is required. Let's sum up again. The example illustrates that the operating mode of a variable area flow meter to measure and display flow is purely mechanical and without auxiliary electrical power. This is an important unique selling point for variable area flow meters.